Hello, everybody. Hello, everyone. So today we will go for the chapter 2, 2.1, and 2.2 for frequency distributions. So we can use the following data of this, all the data right here. So we have to create a frequency distribution for four class. So we have to create that since for four class right here. So we can use this and we can divide this one for that. Okay. So so we know this one is the minimum, and this one we know this one is the maximum. So this one is the minimum right here. So this one is the maximum. Okay. So we have a four class. So we can look up in here. Um, so 1, 2, 3, 4, 5, 6, up to 19, or we can say we have to apply for four class right there. So we can say 1 to 5, 6 to 10, so 11 to 15, and 16 to 20. So we can count this. So 1 to 5, we got 1, 2, 3, 4, 5, 6. So that's one should be 6. So right here, 1, 2, 3, 4, 5, 6. So the frequencies right here is 6. And we continue for the 6 to 10. So we got 10 of them. And from the 11 to 15, we got 4 and then 1. So so we can see this. So we can see this. So at the frequency. So we have to find out the frequency for this for forecast. So we go for the boundary, the class boundary. Um, so because in here we have to get for the range. So that one is from because we have the higher and lower. So we have 19 minus 1, so it's 18. Okay, so 18 divided by 4, we got like 4.5. So, or we said 5 is the length. So this one is the length. So that's why we are this from 5. Each of class right here is the 5. So that's how I get a range. I know at first I do that, but I forgot to tell you. But this one, each of them is this one at the length. So that's one is the 5. So right now, we do the class boundary. The class boundary, we subtract 1, we subtract 0.5 and plus 0.5. So subtract 0.5 for this and plus 0.5 for this. So if we subtract 0.5 for that, so we get we have 0, 5 to the 5, 5, and 5, 5 to the 10, 5. So 10, 5 to the 15, 5. So 15, 5 to the 25. So as we can see this, I can go with all this stuff right here. That's how is the class boundary. And we go for the relative frequency. Relative frequency, like first we total up what we know. We have to find out for the sum. So sum of this. So this one is sum. So this one is 21. So this one is sample size. Sample size. So this one is 21. Okay. So we have to add this up. This one. So one. So this one add this one. We go for this one. So we can have. So now it's 6/21. So that one we get 29%. And we add 10 because 6 plus 10, that is 16. And no, we go for 10. The next one is 10, the next one is 4, and the next one is 1. So we got 10/21. So 10/21, that is 48%. And 4/21, this one is 19%. And 1/21, so this one is 4%. When we add it up, there should be 100%. We add all this one up, there should be at 100%. So the commutative frequency. So now as we add this up, we right here. So we have so this one, I can say this. So this one is 6/21. That's a 29. And we add 10, so that's 16/21. So we got 77%. 77%. Or we can say, because this one we add this up, add this up, add this up, add it up. We can do like that. Okay. So we have that. So right now it's 16 and then 16. So we got we add 4 more. So that's one of 20/21. So 96%. And we have 21/21. This one's 100%. So this one we should check. Should be 100%. Okay. And then right now is the midpoint. So this one we add it up, divide by 2, add it up, divide by 2. So we get 1 plus 5/2, that is 3. So 6 plus 10/2 is 8. And 11 plus 15/2, this one 13. And 16 plus 20/2, this one is 18. So this one is 18. And now we can follow in the data for the car make and the 25 student car. They have a Nissan, they have a Ford. I can put this out here for the notes. This one is Nissan, this one is the Ford, and this one is Honda, and this one is BM. No, this one is BMW. So we can see this. And as we know, the Nissan 1, 2, so we have this. Nissan 1, 2, 3, 4, 5, 6, 7. So that's one is 7. And we do the Ford, the same thing. So that's one is 5. And we do the Honda, the same thing. That's one is 10. And this one 3. So the class boundary, not applicable, non-applicable. So we get NA, NA, NA. So for the relative frequency, so we have to sum. So sum of this one is 25. So we have 7, 25, 7 over 25. So we get 28% and 5 over 25. So we get actually yeah, 20%. And we get 10 over 25. So this one is 40%. And this one is 3 over 25. So this one is 12%. So we should have the total up is 100%. So we have a cumulative frequency. So we get 7 over 25. So this one is 28%. And 7 plus 5, that is 12 over 25. So this one is 48%. And then 8, so this one 12 plus 10, that's a 22 over 25. So we got 88%. And then plus 3, so 25 over 25. So we got 100%. So this one should be 1 equal 100%. And for the midpoint, we don't have it, non-applicable. Non-applicable. So that is for 2.1. So 2.2, we got the graph and we know all that stuff. We use the old one. So this one, frequency, and we can say class. We use it the same thing like the one we had before, 1 to 5, 6 to 10, and 11 to 15, 16 to 20, and the frequency. So we got 6, we got 10, we got 4, we got 1, and this one is 0.5 to 5.5, 5.5 to 10.5, 10.5 to 15.5, 15.5 to 20.5. So as we know all this. So we know that. So this one, we should have so this one is 6. So this one we should have, 6, and this one should be 10, and this one 4, and the lastly is 1. So this one is we call a quantitative. So this one is quantity. So we can say histogram. Okay. So we do the same thing at the bar graph. So is this one a quantitative data. Quantitative data. So as we know the frequency, so this one we have a Nissan, we have a Ford, we have a Honda, we have a BMW. So we get, so Nissan is 7, so 5, this one 10, and this one is 3. So this is the end of chapter 2, 2.1, and also 2.2.